So what I thought we would do today is look at one of the homework exercises from Chapter 7, specifically exercise 7.11, which is the third question on the homework assignment. The question asks, it gives you 6 points of data and then asks you part A, what's the point estimate for the population mean, and part B, point estimate for the population standard deviation. Recall that a point estimate is simply a single number. This will be vitally important when we get to Chapter 8, interval estimation. Now back to the question. Part A is asking for the point estimate for the population mean. We are going to use X bar, or the sample mean, to find that point estimate. Part B is looking for the point estimate for the population standard deviation. That will be the sample standard deviation, which is denoted with the little letter S. The 6 points of data that were given to us were 5, 8, 10, 7, 10, and 14. These come from a simple random sample. A simple random sample means that each item from the population has exactly the same probability of being chosen for the sample. Now we want to find the point estimate for mu. Mu represents the population mean. So in order to do that, we are going to take those 6 numbers and find X bar, the sample mean. The sample means formula looks like this. The numerator has a big sigma, that means summation, with a counter from I equals 1 to n, where little n is the number of data points that we have. Each little x is subscripted by that counter I. So we had 6 data points, so n goes up to 6. X sub 1 would be the first data point, 5, x sub 2, the second data point, 8, all the way out to x sub 6. So then what we need to do is for the numerator add together those 6 numbers and then divide by the denominator, which is little n, which again is the sample size, which is 6. When we do that, we get the following result. 54 divided by 6, resulting in 9. This means our point estimate is 9. X bar, the sample mean, is 9, giving us an estimate for the overall population mean. So we don't know the true population mean. We can only estimate it by using the sample mean, X bar, which is 9. Next we move on to part B, which is going to be asking for the point estimate for sigma. So little sigma is the symbol we use for population standard deviation. To estimate that, we are going to use little s. Little s is the sample standard deviation. Its formula is a little more complicated, but still not too bad. We have everything underneath a square root symbol. Here we're taking positive square roots, not negatives. In the numerator we have a summation symbol again from I equals 1 to n. This time we're taking each individual data point, x sub I, minus x bar, the sample mean we just found in part A. We then square the difference, and we do this again for each data point. We take each individual data point, so the second data point, 8, minus x bar, which we found was 9, take the difference, 1, and square it, 1. We do this for each data point, then we add them all up, the big summation symbol. That's the numerator. The denominator is simply the sample size minus 1, little n minus 1. So here we see that we get the square root of 48 divided by 5, or the square root of 9.6, which gives us approximately 3.098. And that is our point estimate for the population standard deviation. And that concludes exercise 7.11.